one of the technicians in our lab, her daughter is a children of the 90s and has now had a baby, a child of the 90s. So we like, in social medicine in Bristol, doing GWASI type of things. And we thought we'd marry that with things that we care about in our faculty, which is the cell biology of diseases. And the ones we care about are Chrissy Hammond, likes a bit of arthritis action. Becca Richardson, I don't know where she is, likes a bit of heart regeneration. And I'm into cancer. So what we're doing is taking those human disease heads-ups into fish, and these guys are doing fishy things, and they're going to tell you about their fishy things. And first up is Samia. And Sammy wasn't sure whether she was brave enough to use a pointer, but I think she is.
So our next job is to find zebrafish orthologs of the human disease genes identified by GWAS. We're currently being taught by the university group leaders how to use the ZFIN database to identify zebrafish orthologs of the disease genes associated with arthritis, cancer, and heart disease. So this work will be carried out using our school computers to access the GWAS and ZFIN databases with support from the university staff, as well as our head teacher, Dr. Willis, who you can see is very enthusiastic about the project. So, as you know, many diseases are caused by genes that are used to build tissue during development being reactivated or re-switched on. So Chrissy has told us that genes involved in the initial development of joints are often re-switched on again in the adult joint, causing arthritis. And so it's helpful for us to understand the role of these particular disease genes during embryogenesis.
Okay, so about a year ago, the British Heart Foundation used zebrafish as part of their television ad campaign because they can repair their own hearts. And this aids us into work with heart disease, but at Cotham School and Bristol University, we're not only looking at heart disease, but cancer and arthritis too. As Samia just touched upon, there are many parallels between disease and embryogenesis. As you can see here, we've got the same clip as in the first speech, but it's the clip of a magnified embryo, which was a single cell embryo but has divided once already, giving us a pair of cells on top of the yolk. So now you can see it splitting into 4 and 8, and this keeps dividing throughout the day until we have a large clump of cells on top of the yolk. These cells then develop into tissue and spread down the side of the yolk, just like a beanie hat would spread down the side of someone's face. And towards the end of the 24-hour period, you can clearly see a tail, a head and an eye, and stripes of back muscle going down the right side of the yolk. At the University of Bristol, they have hundreds of these Technoclass tanks and are expecting more in the near future. But in Cotham School, we just have the one tank, but it's exactly the same as the ones used in Bristol University. However, the pump has just broken, so we will be talking to the Technoclass guys at lunch. By feeding them on brine shrimp, we are keeping them happy and healthy, and a clear sign of this is that they're already producing and fertilising eggs, which we are able to collect and watch the embryo development of our very own fish.
So together we have decided to focus on 3 diseases, the first of which is heart disease. We understand that the disease appears to recapitulate development. As such, we have studied the development in fish. We have particularly looked at genes to do with repair after heart damage. This is because of the fish's ability to heal its heart without scarring. We find zebrafish really exciting because due to their translucency, we can actually watch the system in real time. So here you can see the heart beating, and we can really appreciate the similarities between the zebrafish and human circulatory system. And for our heart work, we've been working with Becca Richardson. Chrissy Hammond is going to help us look at joint development. Obviously, fish don't have hips or knees, so we're going to be focusing on the jaw joint. We're studying this joint so we can get a better understanding of its development, which will hopefully help us understand some of the causes of arthritis. The final disease we are studying is cancer. For this, we're going to be working with Paul Martin, who is interested in cancer in fish. Again, we look at the translucent embryo from the early stages of development when the cancer cell has just been born, all the way through to the adult stages when the cancer grows and invades, just like it does in a patient. One important thing for us is to get comfortable with using microscopes. We already have some transmitted light microscopes in our school lab. However, some of the fish we're using are transgenic and express green fluorescent proteins. You can see one of our group, Matt, using our new Floyd fluorescent scope. We really like this microscope because it doesn't have eyepieces. We just have to put the fish with the fluorescent cells into the mouth and the screen shows it for us. We use this microscope to look at larval and adult fish so we can study the cells and simple zebrafish systems such as the beating heart. And through a lot of practice, we're actually becoming quite good at microscopy.
So to sum up, we're aiming to learn how to identify human disease genes using genome-wide association studies. This will help us locate the equivalent fish ortholog. After this, we're going to investigate the function of these genes in fish development and then hopefully in our 3 diseases. The project is in its early stages, but as a group of around 30 students, we're committed to propelling things forward with hope of gaining some potential therapeutic implications. And for us as students, it's been a really amazing experience because we get to go beyond the boundaries of the curriculum and carry out work that real scientists, such as yourself, carry out every day. Or as Paul likes to call it, sexy science. Maybe one day we'll be
Sound like a perv, right?
and maybe one day we'll be sitting where you are today. Thank you.